zoned out. I'm sorry. Yeah. So 6 is just saying like find increasing, decreasing, right? Okay. So I'm going to find critical points, which means take the derivative and set the top and bottom equal to 0. Actually, before I do, if I take the derivative in its current form, I have to do I don't want to, so I'm just going to rewrite it as like distribute it. So it's 12 plus 12 cosine of t. And then my derivative 12 goes to 0. And then this 12 will just drop. And what's the derivative of cos? Do you remember that? Negative sine. So this would be negative 12 sine of t. And then I'm always kind of heads up for is there a chain rule? But there's not. But if that was like a 2t, you have to multiply by 2, so remember chain rule exists, so you just don't have to use it here. And then set that equal to 0. So if I divided both sides by negative 12, it's just saying like sine is 0. So in that interval between 0 and 2 pi, where is sine 0? So the sine is the y value, right? So isn't it going to be 0 there, there, and there? Is that fair enough? I don't know if that's too fast. So then I'm going to use those for my, I'm going to build around those. Those are my critical points. So I have an interval, and then, well, I have 0. Then I have pi. And then I have 2 pi. So my intervals, my x value, are from 0 pi, pi to 2 pi. And this is, I'm going to put f, I forgot how we did this. The sine of f prime goes here. Is that how we set it up? And then like, what is f of x doing? And then we put it at the bottom. So the sine of f prime of x is 0 in those spots, so I can just kind of start there. And then I'm plugging into the derivative. So I'm plugging into this. Well, this. So I'm plugging into negative 12 sine of t. Don't plug in like after you divide it by negative 12, because that does change things. Like you took a negative out. So plug into negative 12 sine of whatever. So if I pick a number in between there, like let's say pi over 2. Pi over 2 is up. Any number in between there has a positive y value, doesn't it? The sine is the y value. So any number in this region has a positive y value, but then you're going to multiply it by negative 12. So the sign will be negative, which means f of x will be decreasing. And then between pi and 2 pi is like this bottom part of the circle. So anytime I take the sign down there, the y value is negative, but then I multiply it by negative. So the derivative will end up positive, which means my original is increasing. Is that good? What else? Well, there's 6. What else? What else? Should I do 13 and 14? We'll talk about those. 14? So the process is the same, just set up a little bit more in a confusing way. Where's G decreased? And I can't even see G. Like I can see F, and then I can see the derivative of G has like some stuff with F in it, but I don't even know what the original equation is. I can still find out where it's decreasing though, because decreasing just means I want the derivative to be negative. So I can find out where that is. So I'm gonna go through my process. I'm gonna find the critical points. So that means set the top and bottom of the derivative equal to 0. Well, there is no bottom. So I'm gonna set the top equal to 0, and that's just like a factored form. So then, you know how if I have like x minus 2, x plus 3 equals 0, that's really like set this equal to 0 and you get 2, set this equal to 0 and you get negative 3. Does that make sense what I'm talking about there? So it's the same idea, it just looks more confusing. But you're going to take the f of x and set it equal to 0. You're going to take the f prime of x and set it equal to 0. And then you're going to going to take the x minus 2 and set it equal to 0. I'm going to solve this. Well, f of x equals 0. That's my f of x. So what x value makes that 0 would have to be 4, right? So this gives me x equals 4 as a critical point. F prime of x equals 0. Well, that's my f of x. The derivative of that is negative 1. And if I set that equal to 0, that can never be true, so I don't get a critical point from that piece. And then I do get a critical point here at x equals 2. I'm still just finding critical points, just like I would in a normal equation. It's just set up in a more confusing way, and then I build around those. So I've got x, and then the sign, the sign of f prime. So I've got like negative infinity to 2, 2, 2 to 4. 4, and 4 to infinity. And I'm going to plug into, sorry, this is not sine of f. I'm going to plug into my derivative. So I'm going to plug in, like, for this one I can use 0, because 0 is in between there, so that's probably easiest. So if I plug 0 into this piece, which is f of x, can I erase this part? So if I plug 0 into this piece, f of x, I put a 0 there, positive or negative? Positive. F prime of x, I know is negative 1. That's negative. If I put a 0 into this piece, 0 minus 2 is a negative. So I've got a positive times a negative times a negative, which is a positive. So the sign here is positive, which means g is decreasing. Increasing. What if I was like, what do you mean? Increasing, sorry. I was like so focused on it. Does that make sense what I'm doing to get it? Okay. And then yeah, positive is increasing, my bad. At 2, the sign of g prime is 0, and then at g is just flat, we don't know. So let's plug in like 3. Between 2 and 4. If I plug in 3, 4 minus 3 is a positive number. F prime is still negative, so they're really like in parentheses. And then 3 minus 2 is a positive. So positive, negative, positive means the derivative is negative, so therefore g is decreasing. At 4, my derivative is 0, like that's where the 4 came from in the first place. And then if I were to plug in like 10, any number bigger than 4, 4 minus 10 will be negative. The derivative is always negative. And then 10 minus 2 is positive. So negative times a negative times a positive is a positive. And so we'd be increasing. So they're asking where we're decreasing. So that's from 2 to 4. All right? Did I do 13 too? Sure, yeah. Well, let's see. So this gets into concavity a little bit, which we're starting to kind of build toward. So these are y values. If I were to sketch them, I'll try to do this somewhat accurately because it'll kind of help us. This might be so 1, negative 6, 2, negative 1, 3, 3. 4, 6. And then they're asking us about f prime. So f prime is the slope. So you could just like cross those out and think about what's the slope doing. Well, connect. And I don't know exactly what happens between these points, but I'm just going to kind of sketch like a general. Is the slope positive or negative? Positive. So I can tell that from sketching, or I can tell that from just like, this goes up by 5, this goes up by 4, this goes up too, but all those are positive numbers, so that's the slope is a positive number. But as the slope is positive, isn't the slope itself getting less and less as we go? So you can tell from the graph because it's getting like less steep. If you remember concavity, that's what concave down is. You get that like N type of shape. Or if you look at the graph, my slope is 5, which is positive, but then it's 4, which is still positive, but it's a lower number. This is like we talked about yesterday. Like it's very common that your bank account is positive and is decreasing. So we want that one because your slope is positive, but it's getting less positive as we go. Is that okay with that? Other ones? All right, let's look at. Let's look at 4 first. We'll do these in the concept. Rate of change of fruit flies in Mr. Kelly's kitchen. Show that the number. Okay. What you've got to look at here is, do you have the original, which is an amount, or the derivative, which is a rate? And I think looking through the homework, they give you some that are originals, which is amount, and some that are derivatives, which are rates. So in this one, do I have the derivative or do I have a rate? How do I know? I have a rate, and how can I tell that? The per day is exactly what you're looking for. So that is the rate. So I have the derivative. And remember that if the derivative is negative, we know that the original graph is decreasing. I want to know if the original graph is decreasing. So I plug into the derivative. Well, I have the derivative. So like the common mistake here is to take the derivative of that. Because you see it decreasing, and you're like, oh, decreasing means the derivative should be negative. So you take the derivative. But what you got to realize is you already have the derivative. You already have a rate. You already have a per day or per mile or per whatever it is. So your job is just to find what R of 3 is. You just plug it in. So you would just type in your calculator, what's 6 times cosine of 9, and whatever that is your answer. I think it must come out negative, right? Because it says show it's decreasing. So it's going to be a negative number, and then you have shown that it is decreasing. The part that can trip you up is, like if they had given you flies, if they had said the number of fruit flies in Mr. Kelly's kitchen was this number of flies, then you have the original, which means you have to take the derivative first and then plug in the number. So it just depends which one they give you. Should we go through how to plug in a number and then do the derivative on your calculator again? Should we review that, or is that? Say yes. Yeah, that's fine. So grab your NUTI 89. You guys remember these days? That's what we're doing, integrated math. Just file like regular. You think it's annoying? I think they're fun.
They were like fun once.
It's just like a
got to
puzzle.
like 8, then you were like, I don't want this.
Yeah, I know, that's fair.
Like the first 8 rows.
Right? It makes you feel good. Like, yeah, I'm crushing this.
But then you go check the key and like because I would like try to do it in my head and yes.
And then you feel stupid because you think you're supposed to be smart.
Because I was trying to do it fast because I wanted to get it over.
Right, right. Alright, so make sure you can get to your home screen. I know it's been a minute since we've checked out the calculator. I realized this morning that they're all dead.
Yeah, I just died.
That's a lot. Where did it go?
was on.
Me and Connor are gonna work on graphing. What is this?
I will observe.
Okay. Do you just need new batteries? I have batteries. Do you leave them in your car? Probably free. Does anybody who has working batteries leave it in their car?
Yeah.
Oh, okay. So it doesn't matter. Okay. But if you need batteries, go grab some. They're right over there. Guys, you need batteries? Yes.
Yeah, they're both there.
Oh, for the other guy. All right, I'll wait a minute while half the class gets their new batteries. There's 5 in one of those little packs. Don't steal the 5th one. Give it back to me.
Oh, smash it on your desk like this.
Yes, smash your calculator.
Alright, I'll do it for you.
Just get your fingernail in there and pull it out.
I'll use a pencil.
Like, rip my fingernails.
Yeah, pencil. It works.
Yeah. Or like I've got scissors if you want to pry them out.
That sounds so fancy.
You just bang your calculator on the desk.
That was a very gentle and it wasn't mine.
So it was fine.
Okay, well, I mean, I've had better numbers. The fact that it's frustrating.
Do you recycle your batteries or throw them away?
Throw them on.
Throw them away. Don't put this on me though. You just like those batteries. Throw them away.
We have a little little
So you take them over to cycle.
yeah, we crunch them. Battery lasagna.
I said you put them in your food.
You ever cycle batteries and like laptops and stuff, different electronics. Okay, so just quick review of a couple things on the calculator. Let's say that I wanted to solve. I know you know how to solve this, but let's say I wanted to solve like 4 plus x equals 2. Again, I don't get answer. That's not the point here. I wouldn't use the calculator for no crap. I wouldn't either. Just saying. So you would hit F2 and then solve. And you would type in 4 plus x equals 2. You literally type the equation. And then you put comma x at the ends. Because you're kind of telling the calculator, hey, this is the variable I want you to solve for. And it should tell you -2. Solve is in F2 and then yeah.
Why is your TV having this thing? I was like,
What? Smudge thumper in the middle? I don't know.
can you turn the brightness
Because-
on this one?
No one took the batteries out of it once. Banged it. Can I what?
Can you like change the brightness on this?
Yeah, I was just gonna say that actually. Hit the diamond and then the minus and it'll get lighter. And then hit the diamond and then the plus, it'll get darker.
Oh, whoa.
So you can put it to your, your iris.
That's not. Okay, I that went on my stress.
Well, yeah, hit the
Should I
diamond
help
first.
with the little diamond and then plus?
Hope it's.
Hit the little diamond and then plus or minus, yeah. Did you try to take the batteries off, put them back in? Really?
Noah, hit it.
Do I have no smack?
Trey's haunting us. That's
Trey stole my freaking calculator.
Oh!
Erasmus Jones.
We had to put a little
You better ask my son.
He hurts, bro. Yeah. I just dumped his backpack and left.
someone has.
Where's the Still hot outside.
Okay. So let's say I wanted to, like, I give you f of x equals cosine of x, and I want you to find the derivative. So again, I know that you know how to do that, but let's just do it in the calculator. So just try to review calculator commands. So if you go to F3, what's the easiest for you guys to see? Is that good? Alright. So F3, and then differentiate. And you would type in so second cosine of x. And again, put comma x because you're telling the calculator what variable you want. And then hit enter. It should tell you negative sine of x, which I know you all know. But there it is. Is that good? Alright, let's say I wanted to find f prime of 3. And I'm still working with that, the cosine of x, let's say. So now you do F3 calculator, F3 calculus, differentiate. You still put your cosine of x. You still put your comma x. You still close the parentheses. But now you're going to say, like, oh yeah, evaluate at x equals 3. So you put that vertical line. So you're kind of telling it, like, do this vertical line, and then do this. Then you type in x equals 3. And mine's at, like, approximate, so it's not going to give you the decimal, but that's how you would do it. But that's exact, yeah. Will, you right? If I wanted to put it in, approximate, remember you go mode, scroll down, it'll be like just off the screen. Like mine's in auto, so I'm gonna hit right arrow, scroll down to approximate, I'm gonna hit enter again because it says enter equals save. And now if I type it in, it'll give me the decimal. So you can kind of do both.
Why does it for different calculators go to a different decimal wise? Like mine goes like halfway across the screen.
You can control it, I think.
I think it's exact and approximate.
Well, no, I just put it approximate. So I think you can go here and put like display widgets.
What do you? How do you go back?
So, okay, press the mode button.
So mine says float
Scroll down.
6.
Yeah.
So like you could probably put yours probably at like float 10 or something.
Mine's just float.
Approximate.
So that just floats until it's, I don't know. I don't really know, to be honest. Okay, what you want me to do the exact approximate thing again? Is that what you're saying?
Which one? Which one do I press? Exact or approximate?
So exact will give you
It's
a
exact.
sign of 3. And approximate will give you a decimal.
Well, like sometimes you'll do a multiple choice and the answer's a decimal and you want the approximate. And sometimes you do a multiple choice and the answers are like sine of 2. Then you want, you know what I mean? It kind of depends. Yeah. Okay. Let's say I wanted to graph. Let's say this is the question. Y prime equals e to the x. Where is y increasing? So we're going to graph this. I can't graph y. I mean, I could. You guys probably can too. If y prime is e to the x, what's y? E to the x. Like the derivative of e to the x is different. But let's pretend we don't know that. I don't know what y is. But I can tell where it's increasing by graphing the derivative. That's what we did yesterday. If the derivative's above the axis, what is the original function doing? Increasing. If the derivative is below the axis, then the original function is decreasing. So let's graph it. So go diamonds F1. That's like number 10 or something. I was looking at the problems earlier. And type in e to the x. E is the diamond and then the x button. Okay there. And then hit graph, so that's diamond and then F3. And you can't really tell this, but that graph is always above the x-axis.
Oh, there's points
what's true about the original graph? I get you interrupted my flow
It's
here.
increasing.
Yeah, so if the derivative, just grab more batteries if you want.
I know it. I'm taking them out.
So if the derivative's always above the axis, what's true about the original? It's always increasing. Let's say it was e to the x minus 1. We're just going to change it a little bit. And I'm going to ask you, where is the original graph increasing? Remember, this is the derivative. We're graphing the derivative. I can't make it say like y prime. I just got to hit my head and be like, okay, that's the derivative. So make it e to the x minus 1. So now if I said, where is the original graph increasing? We're going to pretend that we don't know that goes through the origin. And I'm going to show you how to find that it goes through the origin. So hit. Does everybody have this graph before I like move on too quickly here? Okay, everybody, Willie, you guys okay? Okay. We got everybody sees this graph? So let's make sure that it actually goes through 0 and not like 0.1 or something. So hit F5. And then 0. And then you're going to do lower bound, upper bound. Lower bound, upper bound are left and right. So you're going to move your cursor over to the side a little bit and hit enter, and it'll put like an arrow there. And then move your cursor to the right, and it'll put an arrow there. And it'll look between those two things, where does it cross the axis? And that's what we're trying to see. So I'm going to go to the left a little bit. You see that little like arrow it puts up there? And say, okay, I'm going to look on that side of that. And then it'll put another one that's like really fast, you can tell. And so it does cross the axis at x equals 0. I'm just like confirming that and reviewing how to like do that with you. Questions on anything I just showed you? Is that like familiar? Look, you've done it before, right? I know it's been a while, but it's familiar-ish.
Yeah.
Ish. Okay. Well, let's practice it. So I want you to do.
Can't you like differentiate from this?
I can find the derivative at a point, yeah. So you would do F5 and then differentiate, and then. Is your batteries are good? Okay.
The other one's corroded.
So do number 7 through 12. Like right now in class, and then I would like to maybe get to number 15 as well, but maybe not. We'll see. So try these. So there's calculus involved and also like just